Hey Math 110 students, this is Brother Duncan. Today is the 24th of February 2012, so this is Friday. Today we just finished discussing, or started discussing compound interest, what happens when we compound continually. I didn't feel that the lecture was sufficient, and there was a question brought up in section 6, that was at the 11 o'clock hour, which I wanted to answer. I didn't have a good answer at the time. And the question was, why are we taking our percent rate, our annual percentage rate, our APR, and then dividing it by a number? Seems kind of counterintuitive, since previously when we had a growth rate, we raised that growth rate to a root of some kind, like to the 1/2 power or to the 1/4 power. So it would seem natural that an APR of, say, 12%, that we would raise it to, if we wanted to find out the monthly growth rate, we would raise it to the 1/12 power, because there's 12 months in a year. And that bothered me, because it makes sense that we would do that. So I had to do some digging, and I came up with the reason why we're doing this division of the rate of how much we're changing, that APR. Why we divide first, then add it to our initial amount, that's the +1, and finally raise that whole thing to a power. So I've also created a document which I suggest that you have open. It will go with this audio. That document is found in Google Docs, and it's under the notes section, so it would be the notes for the 24th of February. It's farther down the page. So I had a conversation with a colleague about this, and this is what I came up with. And this is going to go right along with what you see on the page. So if you want to pause the video and pull the page up first, that makes good sense. So I believe that compound interest actually originates in something we call simple interest. And this is how simple interest works. So suppose I invest a principal amount, let's say $1,000, and it has a simple interest rate of 12% per year. That means once a year, I get a return of 12% on my principal amount. If I wait another year, I'll get 12% on the same principal amount. So 12% of 1,000, that's roughly $120. So after 1 year, I get $120. Okay. The next year, I get another $120. So basically, after 2 years, I get $240. You notice this progression, it looks linear, and that's because it is. And the formula we use for simple interest is our return is equal to the principal times what my rate is times time. So my rate per year was 12% per year. My time was 1 year or 2 years or 3 years. And then my principal amount was $1,000. And the amount I get back, the output for that, is the return I get on my investment. It doesn't include my initial investment, just how much I'm getting back on my principal amount. So here's what I think. We started off this way. I'm pretty sure this is how it worked with banks and why they came up with this convention. So originally, I wished to invest that $1,000, but I want to have it paid out throughout the year. So I don't want to wait a full 12 months or however long it is up to that year to get paid. I want them to give me small amounts along the way. So say I want them to pay me out every month. Well, the amount paid out each month will always be the same amount, since simple interest doesn't do any kind of compounding. So it would be just 1/12 of my yearly return. So if I have $1,000 and my percent rate is 12% for my APR, that means that every month I should get 1%. And then each month that'll add up, that'll accrue up to 12% after 1 year, getting paid 1% per year. That makes sense to us. So that basically means instead of getting $120 after 1 year, I'm going to get 1% of 1,000. That's $10. So after 1 month, I get $10 in the mail. That's my return on my investment. I wait another month, same principles in there, $1,000. So I'll get out another $10. So I've gotten another $10. So over a 2-month period, I've now accumulated $20. After a 3-month period, I've accumulated another $10. So I've now got $10, $20, $30. And this keeps going until we hit the 12-month mark. And now I've gotten all $120 that I was expecting to get. I just got it at the end of each month instead of at the end of the year. So now here's the hook. The thing is, and at this point you should be through that first picture. That first picture basically illustrates this. Simple interest does not account for what I do with that return. So after 1 month, they give me that $10. They don't account for what I do with it. So what happens if I reinvest that $10 with the $1,000 I already had? So now instead of having $1,000 as my principal, I have $1,000 plus $10. So I have $1,010 as my principal. So now they have to take 1% of $1,000, $1,010. So 10% of that, that's going to give me a return of $11. So the picture at this point should be pretty illustrative of this. It tells you I start with $1,000, my return is $10. In red it says, well, I'm going to reinvest that $10 with my original $1,000. So I've got $1,010 in my principal, right? After another month passes, I get 1% back on that investment. So 1% of $1,010, that's $11. So I made a little bit of extra money this time around. I didn't make $10, I made $11. Now suppose I continue this pattern. So now I've got $11 as my return. I take that $11 and I redeposit it with my principal amount. Remember, my principal amount now was $1,010. I'm now going to add another $11 to it. So I should now be up to $1,000, $1,021. So $1,021. That's my second month investment. And then I get my second month return, third month return, and it keeps going, it keeps going. Finally, my 12-month investment is up to $1,115.67. So I now take 1% of that, and that gives me a total of $1,126.83. Now the question I have is, that's the amount we get. That needs to be edited. We get $126.83 as our return. That is what our return is on that initial investment. So $126.83. That's quite a chunk of change we have there. And in fact, we started with only getting $120 back for the year, but now since we're compounding this, right, every time we take our investment, we get a return, we take that return and add it to our investment, and then it gets compounded on as well. So it grows, and the little bit we added in grows as well. So instead of getting $120 back, we're going to get $126.83 roughly back. Now what this looks like as a formula is we start with 1,000, and we multiply that times 1 plus 0.1, 1 being our initial amount, and 0.1 being the amount we're going to get as a return on that $1,000. If we reinvest that return plus our initial investment of $1,000, we're going to basically take 1,000 times 1 plus 0.1. That's where we get that $1,010. We're going to multiply that times 1 plus 0.1. Why are we multiplying by 1 plus 0.1 again? That 1, of course, represents the initial amount, and the 0.1 represents the 0.01 represents the amount we're getting as a return on our investment. So as you can see, the more often we do this, we're basically taking 1 plus 0.1 and we're raising it to a power. Every time each month goes by, that power goes up by 1. First it's 1, then it's to the second, then it's to the third, until we get $1,000 times 1 plus 0.01, that's our 1%, and that's being raised to the 12th power because we've done this compounding now 12 times. Our final answer now is how much interest we've generated after 12 months by compounding our principal and then our return added to our principal, compounding that, continuously doing this cyclically for 12 cycles. And that is where we get compound interest from. I don't think I need to give you a discussion about where E comes from. We discussed that today in class, and on Monday, of course, we'll reiterate where that comes from, and we'll get a chance to see how E basically is what comes out of us compounding things more often and more often and more often. We see that it kind of reaches a limit that you can't get any more out of your investment. You've basically milked it dry. There's no more you can squeeze out of this investment. And that limit it's reaching is E. All right. If we have more questions, there may be another video, more to come. Until then, I hope this has helped make sense of compound interest. Give me some feedback. Let me know, and I'll talk to you later. See you in class.